Hey everyone, hope you're doing well. Today I'm going to teach you how to tackle this question up here, which is d over dx of e to the minus x squared times sine of 2x. It's a bit early here still, so I'm trying not to talk too loudly, but I'm going to go through this question and I'll teach you how to tackle it step by step and explain all the working and steps along the way. Obviously, we've got it all written out. It is quite easy. I'll just show you what to do as we go along. That as u times dv over dx plus v times du over dx, and that is effectively a successful differentiation. And secondly, we're going to use the chain rule, and that is that if you have, if you want to differentiate, f of g of x, which is, I guess, a function within a function, you can rewrite that. And secondly, we're going to use the chain rule, and that is that if you have, if you want to differentiate, f of g of x, which is, I guess, a function within a function, you can rewrite that as f dash of g of x times g dash of x, and that will also count as a successful differentiation. So what we're going to do is we're going to use the product rule to, actually, it might make sense. I'll explain the product rule first. I'll show you the components of it and how this applies to our question. So let's start applying the product rule. We have our u and v. So we'll define u is equal to e to the minus x squared and v is equal to sine of 2x. So I guess technically nice and easy. Now we can just say, okay, well, now we just need to get du over dx and dv over dx, and then we'll have all four components to complete the product rule up here. Unfortunately, at least from my understanding, these aren't easily differentiable. We're going to need to use the chain rule for both of them. So we'll use the chain rule for each of those to get the du over dx and the dv over dx, and then once we get that, we can just combine it all together. So let's first get du over dx. So u is equal to e to the minus x squared, and we need to use the chain rule. Okay, so for the chain rule, we need to define f of z and g of x. Like I said before, the function within the function. So our f of z function will be e to the power of z, and our g of x is minus x squared, because when we pop that into here, the z will be the minus x squared, okay? Feel like that could be a bit confusing to understand, but bear with me, maybe it will click. If it doesn't, or if you do understand it, all great. Now we need to do the differentiation of f of z and g of x. So that's what the dashes are. It means they're differentiated. So f of z, or f dash of z, is just ez, it stays the same, and g dash of x, this becomes minus 2x, okay? Like just a simple differentiation, bringing the power to the front. So now we can use the chain rule to work out du over dx. So that is going to be equal to, we have f dash, where's f dash? It's here, so it's e to the power of z, and we need to put g of x into it, so e to the minus x squared times g dash of x minus 2x, and then we're just going to rewrite it as minus 2x times e to the minus x squared. And when I say rewrite, we just made it a bit cleaner. We've just, brought it all together, so nothing crazy. So we've got three of the four components now. We have du over dx, the u and the v. Now we need the dv over dx. So let's differentiate sine of 2x. Now, you may or may not have noticed that I probably should have used different annotation instead of the same f of z times g of x, or g of x, as not to, mix them together. If you're doing this like properly, I mean, I guess you should probably define them as something else, but I suppose for the video it makes sense because you can relate it back to this a bit better. So I guess there's pros and cons to both, but just take that into account if you're doing this in your own time. I suppose it's just because we're using a chain rule on two different things. So yeah. Anyway, so v is equal to sine of 2x. So we've got our definition of f of z is equal to sine of z, and our g of x, our function in a function, I guess, is 2 of x. So, and f dash of z, so sine of z differentiated, is cos of z, and g dash of x is going to be 2 because we just get rid of that x there. Now from here, we will use the chain rule for dv over dx. So it's going to be equal to f dash of z, so cos of z, but we need to put g of x into the function, so we've got 2 of x into the function, and it's going to be times by g dash of x, which is 2. So that's going to be equal to 2 cos of 2x, yeah? And now we've effectively got everything we need to combine and use the product rule. We've got u, v, du over dx, and dv over dx. Yeah, we got the v part and the u part all sorted out. So all we need to do is sub in the u, v, du over dx, and dv over dx into this here, and we will have our final answer. So at the bottom here, I've just rewritten the question. I mean, I've just kind of taken up space. I don't know if I have to do that, but it's going to be equal to u times dv over dx, and in this case the u is e to the minus x squared, so we've got that here, times the 2 cos of 2x, plus the v, where's the v, sine of 2x times du over dx, and that is minus 2x times e to the minus x squared, okay? On the next line, we're just rewriting it to make it a bit cleaner. So we've got 2e to the minus x squared times cos of 2x minus 2x times e to the minus x squared times sine of 2x. And the last thing we're going to do is take out, I guess you call it a factor, right? I should know that. You take out 2e to the minus x squared because that is in both of these components. And I think that's the final answer, as simple as you can do it. I don't know whether you can, sometimes you can simplify cos and sine, but I think that's it. So hopefully that answers the question. You might not get this exact question, obviously, so you might have a similar one, but hopefully that gives you some sort of practical understanding. You can drop some questions below. I don't know if I'll be able to help. I can try, but there's no guarantee. But yeah, I mean, I just say practice, and yeah, I can, if you want, I can try help. If you do leave a comment, I hope it helped. Hope it was clear, and yeah, you can let me know if you got any comments. I appreciate you watching the video if you made it this far. So yeah, thanks for watching. I hope it helped.